Welcome to the law offices of Chris M. Ingram's Immigration News Show. Today we ask, can $52 billion in new factories succeed without the immigrant engineers to run them? We'd like to thank attorney Chris M. Ingram and staff at the law offices of Chris M. Ingram for their hard work in preparing the research for this show, which draws on a wide variety of news sources from both sides of the aisle, providing a balanced view. Attorney Ingram is also a vocal advocate for the rights and protection of immigration applicants, although our coverage is designed to be nonpartisan. Please don't forget to like, follow, and subscribe to our channel. We are also on Spotify, YouTube, LinkedIn, Facebook, X, Reddit, and Instagram, where we're growing rapidly thanks to our social media team. You can also visit our website on www.breakthroughUSA.com, and we'd love to see you there. Disclaimer. Please note that this presentation should not be intended as legal advice for your specific situation. If you, a friend, or a family member would like a free consultation, you can visit our website at www.breakthroughUSA.com and schedule an appointment. We'd love to hear from you and help you if we can. We'd also like to point out that this presentation was created using AI hosts. Okay, let's dive in.
Honestly, it is so fantastic to be here for this one. This is such a massive topic.
It really is. So I want you and our listener to just imagine something for a second. Imagine spending, I don't know, $52 billion to build the most advanced state-of-the-art hospital on Earth.
Okay, $52 billion, that's a lot of hospital.
Right. And you spare absolutely no expense. You buy the newest, most sophisticated MRI machines. You construct these pristine surgical suites. The lighting is perfect. The architecture is stunning. But then on opening day, you realize you completely forgot to hire any actual surgeons to perform the operations.
Oh, wow. Yeah, so you've essentially just built a very expensive empty building.
Exactly. An incredibly expensive empty building.
Yeah.
And following the legal research prepared by our team, we're looking at a staggering reality that mirrors this exactly. America is currently building massive, unprecedented semiconductor factories in the desert, but we are facing a terrifying shortfall of 67,000 engineers actually needed to turn the lights on.
It is the ultimate bottleneck. I mean, it really is. And to understand the sheer gravity of that missing human capital, we first have to, ground ourselves in what we are actually trying to build here.
Right, because it's not just regular factories.
No, not at all. When we analyze the briefing documents our legal team shared with us, the foundational truth is that semiconductor chips are the invisible infrastructure of modern human existence.
Yeah. We talk about like tech and the cloud abstractly, right?
Yeah.
As if these things just sort of live in the ether.
Exactly.
But the reality is highly physical.
Completely physical. Every single smartphone sitting in your pocket. Every electric vehicle navigating the roads, the massive server farms powering cloud architecture.
All of it.
And every single artificial intelligence system processing data right this very second, they are all utterly reliant on physical wafers of silicon.
Right.
If you sever the supply of those chips, the modern economy does not just slow down, it stops cold.
You literally don't think about it until you can't get it. And looking at the research Chris Ingram's team compiled, what becomes incredibly apparent is the sheer, terrifying vulnerability of how we've been operating for the last few decades.
Yeah, it's actually pretty scary when you look closely.
We allowed this entire essential global supply chain to become overwhelmingly concentrated in one place.
Taiwan. Specifically, the global economy became completely tethered to the fabrication facilities, or what they call fabs, of one single entity, TSMC.
The Taiwan Semiconductor Manufacturing Company.
That's the one. For a very long time, almost all of the most advanced leading-edge chips on the planet were manufactured exclusively on that island.
Which, just from a supply chain perspective, is pure insanity. I mean, you have this incredibly delicate, highly specific bottleneck, a single severe typhoon hitting the island, or, a single geopolitical military miscalculation in the region, and suddenly the entire global economy stalls.
Everything just halts.
You can't build cars, you can't manufacture medical equipment, you can't deploy servers for AI. It's wild.
And that profound vulnerability is exactly what birthed the CETS and Science Act, which was signed into law in 2022.
Right.
The U.S. government finally looked at the board and decided that, hey, the concentration of advanced chip manufacturing abroad is an unacceptable national security and economic risk.
It's just too dangerous.
Exactly. So they made a historic commitment. $52 billion in direct federal funding, specifically engineered to rebuild semiconductor manufacturing right here on American soil.
Okay, let's unpack this, because $52 billion is an astronomical amount of federal backing.
It really is.
That is essentially the government trying to brute force an entire industrial sector back into existence domestically.
It is brute force, yeah, but it was paired with a highly strategic incentive mechanism.
Okay.
Alongside the direct funding, the CHES Act authorized a 25% tax credit for qualifying capital investment in domestic fabs.
Which is huge.
Massive. When you consider that a single modern fabrication facility can cost upwards of $20 billion to build, a 25% tax credit radically alters the corporate math for these massive tech companies.
And the private sector's response was explosive, wasn't it? Like, the data and the legal research shows a complete gold rush.
Explosive is definitely the right word. According to the Semiconductor Industry Association data featured in our research, since the CHES Act passed in 2022, private companies have announced more than $540 billion in private investment.
$540 billion. That's,
Yeah.
I mean, wow.
Yeah. We are talking about more than 100 semiconductor projects sprouting up all across the United States.
So the federal government puts up $52 billion, and the private sector essentially 10 times that amount.
Precisely.
That isn't just an investment. That is completely redrawing the industrial map of the country.
It is redrawing the map, and the absolute epicenter of this tectonic shift is happening right now in the Arizona desert.
Right, the TSMC site.
Yeah. TSMC is building what could legitimately become the most consequential manufacturing cluster in American history. The scale is, frankly, difficult to even comprehend.
It's just massive.
Unbelievable. Their first massive fab, known as Fab 21 Phase 1, is designed to produce 4-nanometer chips, and it targets high-volume production for early 2025.
And just to clarify for everyone listening, when we say 4-nanometer chips, we are talking about the absolute bleeding edge, right?
Well, absolutely.
These are the chips driving the massive Apple ecosystems and those heavy-duty NVIDIA processing units.
Exactly. These are the engines of the AI revolution, and they aren't stopping with Phase 1.
They're already expanding.
They are moving at breakneck speed. Equipment installation for their second fab already began in mid-2026.
Wow.
That facility is designed to push the boundaries even further, running 3-nanometer process technology with production targeted for 2027.
That is incredibly fast for facilities of this complexity.
It is, and the long-term blueprint TSMC has laid out. Plans are in place for up to 6 wafer fabs, 2 specialized advanced packaging facilities, and a dedicated research and development center, all localized right there in Arizona.
Okay, so on paper, if you just read a press release, this looks like an overwhelming victory for the U.S.
It sounds like a total win.
Right. The federal money is flowing, the massive private capital is deployed, the dirt is moving, and these colossal facilities are rising out of the desert. But here is where the briefing documents from attorney Chris Ingram stop you dead in your tracks.
I am currently working with Alexandra Rodriguez on my EB1 petition, and the experience has been exceptional. We are in the final stages of the filing process, and I have been thoroughly impressed by her consistency. Alexandra provides proactive weekly updates and is incredibly responsive to every question I have. Since she took over my case, the momentum has increased significantly, and we have efficiently navigated the complex requirements. I highly recommend her for anyone looking for a diligent and fast-moving immigration attorney.
There is a gaping hole in this strategy,
A massive one.
a fatal flaw that policymakers seem to have just glossed over.
Yeah. If we connect this to the bigger picture,
Right.
we have to recognize that authorizing the funding, breaking ground on the concrete, and shipping in the multi-million-dollar equipment that is only half the equation.
Right, you still need the people.
Exactly. National security and true economic stability don't just rely on physical infrastructure, they rely entirely on human capital.
And we just don't have it.
We don't. The Semiconductor Industry Association is projecting a massive shortfall of approximately 67,000 semiconductor workers in the United States by 2030.
This is the hospital without surgeons. I have to stop and wrap my head around this.
It's hard to believe, isn't it?
We authorized $52 billion in taxpayer money. We spurred $500 billion in private money to build all these state-of-the-art facilities, but we fundamentally failed to calculate the human beings required to actually run them.
That is precisely the reality. The 67,000 worker gap is a combined shortage of technicians, process engineers, and computer scientists.
That's a huge number of highly skilled people.
It is. And within that massive deficit, design engineers with direct experience in advanced packaging and sub-3-nanometer process nodes are among the most sought-after, hardest-to-find talent in any industry on the planet right now.
So they're basically unicorns.
Essentially, yes. The physical fabs are rising from the dust, but the hyper-specialized workforce required to actually operate the clean rooms and manage the yields is simply not keeping pace.
It's maddening because, you can build a massive concrete and steel building in a year or two if you throw enough money at it.
Sure.
But you absolutely cannot manufacture an experienced, specialized semiconductor engineer overnight. You can't just run a 6-week boot camp and tell someone, okay, go manipulate silicon at the atomic level now.
No, you definitely cannot. And I want you, the listener, to really internalize how this specific bottleneck affects you.
Yeah, it's not just a corporate issue.
Not at all. Think about how vulnerable your daily digital life is right now. The phone you use to manage your life, the car you drive to work, the cloud servers that hold your personal data and banking information. They all depend on closing the 67,000-person gap.
That's a huge deal.
This isn't some abstract corporate hiring problem. It is a fundamental pillar of national security.
Which brings us to a fascinating pivot in the research. To really understand how we lost this manufacturing edge in the first place and exactly the mechanics of how we are trying to get it back, the legal research from our team points us backward to a specific historical figure.
A brilliant figure.
We need to look at the man who essentially engineered the modern semiconductor manufacturing industry. And crucially, he was an American immigrant.
Yes. His name is Morris Chang. And analyzing his story isn't just a history lesson. It is the fundamental blueprint for everything happening in the immigration and tech landscape today.
Let's trace his journey because the historical context is incredible. He was born in 1931 in Ningbo, China. He grew up right in the terrifying middle of wartime upheaval. He had to flee first to Shanghai and then to Hong Kong as the Chinese Civil War was literally tearing his country apart.
Just unimaginable circumstances.
And then, in 1949, at the age of 18, he crosses an ocean. He comes to the United States with practically nothing but raw ambition and a profound belief that American educational institutions could forge his future.
And look at how deeply those American institutions invested in him and how he capitalized on it.
It's amazing.
He enrolls at Harvard. He then transfers to MIT, where he earns both his bachelor's and master's degrees in mechanical engineering.
Two of the best schools in the world.
And it doesn't stop there. Later, his employer at the time, Texas Instruments, recognizes his brilliance and actually sponsors his doctorate at Stanford University.
Wow. Sponsored by TS.
Yeah. He earns his PhD in electrical engineering there in 1964. And critically to this story, he became a U.S. citizen in 1962.
So he is absorbing the absolute best education the United States has to offer. Harvard, MIT, Stanford.
The trifecta.
And then he embeds himself at Texas Instruments, where he grinds and rises steadily over the course of 25 years. He eventually becomes the group vice president responsible for their entire global semiconductor business.
A massive role.
But during those decades at TI, he observes a friction in the market that nobody else seems to fully grasp.
It was a paradigm-shifting observation. Chang realized that electronics companies increasingly wanted to design their own specialized chips, but the barrier to entry for actually manufacturing them was insurmountable.
It's expensive, right?
Exactly. The capital cost of building a fabrication facility was enormous, and the highly specialized expertise required to run the delicate machinery was incredibly difficult to maintain.
So they just couldn't do both.
Right. Many brilliant design firms realized they would rather outsource the manufacturing step entirely so they could focus purely on architecture and innovation.
Makes sense.
But there was a massive structural problem. Nobody had yet built a company designed specifically to just manufacture chips for other people.
Okay, let me push back on that for a second.
Wow.
Why was that such a radical idea? Weren't companies like Intel or Texas Instruments already building chips? Why couldn't a design firm just go to Intel and say, hey, build this for us?
Because back then, the entire industry was built on the integrated device manufacturer, or IDM, model.
Okay.
Companies like Intel and TI designed their chips and they built their chips in-house. The prevailing business logic of the 1970s and 80s was that design and manufacturing had to be tightly coupled. American executives fundamentally believed that if you separated the design from the fabrication, you would lose quality control and efficiency. They viewed manufacturing as a proprietary advantage, not a service you offer to competitors.
Ah, I see. So when Morris Chang leaves Texas Instruments and starts pitching this idea of a standalone manufacturer, he's basically telling the dominant American tech giants that their entire vertically integrated business model is holding the industry back.
He was challenging their entire worldview.
And the research notes that he literally pitched this idea to them. He pitched it to Intel, and they turned him down. He pitched it to his old bosses at Texas Instruments, and they turned him down. They just didn't see the vision.
They completely missed the paradigm shift. They couldn't see that standardizing the manufacturing process would democratize chip design for the entire world.
So what did he do?
Eventually, the government of Taiwan reaches out to him. They provide the backing alongside the Dutch company Philips. And in 1987, Morris Chang founds TSMC.
And he essentially creates the pure play foundry.
Exactly. A company that strictly manufactured chips for other companies and did absolutely nothing else. No in-house designs to compete with their clients. Just pure, unmatched manufacturing excellence.
And, wow, history has delivered a brutal, definitive verdict on those early rejections by Intel and TI.
Very brutal.
Because today, TSMC is the central, most critical node in the entire global technology supply chain. If you are holding an iPhone or utilizing an NVIDIA GPU for deep learning or accessing an AI data center, the leading-edge chips powering those devices almost certainly pass through the hands of TSMC.
Which brings us to the profound realization embedded in the research provided by our team. If we look at the mechanics of global innovation, America's technological dominance has always relied heavily on importing, educating, and nurturing brilliant minds from across the globe.
So what does this all mean for us today? It means the cycle is completely interconnected. You have an immigrant who came to the U.S. fleeing a war. He is trained in our premier institutions. He builds his deep expertise over 25 years inside an American corporation. He becomes an American citizen.
Yes.
He then uses all of that American engineering discipline and commercial instinct to invent a revolutionary business model abroad. And now, decades later, the United States government is relying on the exact company he founded and its Arizona fabs to execute its central strategy for domestic chip sovereignty.
The immigrant became the architect of the industry that America now desperately needs to rebuild at home. And as our legal research points out, we shouldn't view this as irony.
Right, it's not ironic at all.
This is simply the fundamental reality of how global talent and innovation operate. Capital follows talent, and innovation doesn't respect borders.
Which transitions us perfectly to the present day. Because history is essentially repeating itself right now, right out there in the Arizona desert.
It is happening again.
The Morris Changs of today, the next generation of brilliant global talent, are already here. They are actively building the next era of technology, but they are facing a completely different, frankly maddening set of bureaucratic hurdles.
Yes. To understand the reality on the ground today, our attorneys provided a case study that is incredibly illuminating. I want to introduce you to Elena Kaufman.
Okay, let's talk about Elena.
She is 37 years old, originally from Stuttgart, Germany. She's a highly specialized semiconductor process engineer who spent 8 years honing her craft at Infineon Technologies, one of Europe's leading chip makers.
And her specific skill set is absolutely vital to this 67,000-person shortfall we talked about earlier. She specializes in advanced packaging.
Yes.
And specifically areas called heterogeneous integration and chiplet assembly.
What's fascinating here is why advanced packaging is suddenly the most critical bottleneck in the entire tech industry.
It sounds super technical.
It is. So we need to elevate the technical conversation here for a moment. For decades, the entire semiconductor industry operated on the principle of shrinking the size of a transistor.
Right.
You make the transistor smaller, you fit more of them on a monolithic piece of silicon, and the chip gets faster and more efficient.
Right. Everyone knows Moore's law, but you can't just shrink things forever.
Precisely. Because we are now hitting the physical reticle limits of Moore's law.
The laws of physics are getting in the way.
Exactly. You are dealing with structures at the atomic level, where quantum tunneling and thermal dynamics create massive physical barriers. You literally cannot make a monolithic chip much larger, or its transistors much smaller, without the entire thing failing or becoming prohibitively expensive due to defect rates.
Okay, let's unpack this. If you can't build one massive, perfect chip anymore, what is Elena's specialty actually doing to solve that? Like, what exactly is a chiplet?
Think of it like microscopic Lego blocks.
Okay, I like that.
Instead of trying to print one massive, flawless, monolithic chip, which is incredibly difficult and expensive, you print smaller, specialized chips called chiplets. One chiplet might be optimized for memory, another for processing, another for data transfer.
Got it.
Heterogeneous integration is the incredibly complex science of taking all these different chiplets, stacking them tightly together in 3 dimensions, and connecting them so perfectly that they function as a single, incredibly powerful unit.
That's fascinating. So you're no longer just shrinking nodes on a flat surface. You're stacking them architecturally to bypass the laws of physics.
That's exactly what it is.
And Elena's exact specialty is overcoming the thermal dynamics and the microscopic connections required for that 3D chiplet stacking.
Exactly. And the engineers who know how to successfully execute heterogeneous integration are among the most sought-after professionals on Earth.
I can imagine.
These are not commodity skills. They are highly specialized structural necessities for the next decade of artificial intelligence.
So Elena knows exactly what her skills are worth on the open market. And when TSMC started aggressively expanding in Arizona and drawing talent from around the globe, she gets an offer she can't ignore.
A lead process engineering role right on the advanced packaging team.
Right. So she accepts the role, she uproots her life, she moves to Phoenix, Arizona, she arrives in the U.S. on an H-1B visa sponsored by TSMC. And initially, the work is everything she wanted. The sheer scale of the Arizona project, the cutting-edge EUV tools, the international collaboration with engineers from Japan, South Korea, India, Taiwan. She feels the tangible strategic importance of what she is physically building.
It's an engineer's dream. But then the honeymoon ends and she hits the bureaucratic reality of the United States immigration system.
The dreaded H-1B.
Yeah. The H-1B visa is a temporary work visa. It comes with a ticking clock. It has strict statutory time limits.
Right.
And Elena found herself in a deeply precarious situation. Her employer, the massive corporation that recruited her, had not initiated a permanent green card process for her. Yeah, they hadn't explicitly said no, but they hadn't said yes either. They were just stalling, leaving her completely in limbo.
And this is where I really had to push back, because it defies all logic. Why on earth would a massive multi-billion-dollar corporation spend a fortune recruiting top-tier, highly specialized global talent for a $52 billion national initiative, physically move them across the world, and then drag their feet on a simple green card application?
It's crazy, isn't it?
It makes absolutely zero business sense. If they need her so badly, why risk losing her to a visa expiration?
From the outside, it seems entirely illogical, but from the inside of a massive corporation, it comes down to immense bureaucratic friction.
Just red tape.
So much red tape. You have to remember how these HR departments function. You're dealing with massive corporate budget cycles where legal fees for immigration are scrutinized and capped every quarter.
Yeah.
You have HR bottlenecks where a centralized department is managing thousands of employees and often treating a highly specialized advanced packaging engineer with the exact same standardized timeline as a mid-level manager in accounting.
So it's not malicious, it's just administrative inertia.
Exactly. And layered on top of that is the H-1B system itself, which complicates timelines and adds constant uncertainty. The corporation figures, well, we have her for a few years on this visa. We don't need to rush the permanent residency until the last minute.
But that's so stressful for her.
It creates a terrifying system of limbo for the employee.
It's maddening. I want you, the listener, to just imagine this for a second. Imagine uprooting your entire life, moving across the world to do vital, highly specialized work that the federal government considers a matter of literal national security, only to realize that your entire future, your ability to stay and finish the job you were hired to do, depends entirely on an HR department's arbitrary quarterly budget timeline.
And for Elena, being from Germany, her issue wasn't the multi-decade visa backlogs that Indian or Chinese nationals face in the standard employment-based green card queues.
Right, the country caps.
Yeah, her country of birth wasn't oversubscribed. Her specific challenge was purely corporate friction. If the company didn't file the petition, she was stuck.
But she didn't just wait around hoping HR would eventually figure it out. She took agency.
She did.
She started digging into U.S. immigration law herself. She found BreakthroughUSA.com, and she started reading the studies and legal research from attorney Chris Ingram. And that is how she discovered the legal key to her dilemma.
She discovered the EB-2 National Interest Waiver, commonly known as the NIW.
The NIW.
Yes, and we need to explain its immense power because it completely changes the power dynamic for someone in Elena's position. The EB-2 NIW allows a qualified professional to self-petition for a U.S. green card.
Hold on. Self-petition, meaning she doesn't need TSMC to do it for her. But if she's already here on a visa sponsored by TSMC, won't TSMC find out she's self-petitioning, Doesn't that create massive friction with her employer?
That is a very common fear, but the beauty of the self-petition is that it is entirely independent of the employer. TSMC doesn't have to sign it, they don't have to pay for it, and they don't even necessarily have to know she is filing it.
Wow.
No employer sponsor is needed. Furthermore, there is no PERM labor certification process required.
And we should explain what PERM actually is, because it sounds benign, but it's a nightmare, right?
A bureaucratic nightmare. PERM is an incredibly lengthy, expensive process where an employer has to prove to the Department of Labor that they couldn't find an American worker for the job.
Right.
They literally have to post advertisements in Sunday newspapers, wait for months, review resumes, and prove a negative. It can take over a year just to get through that single step.
Just waiting to see if someone replies to a newspaper ad.
Yes. The national interest waiver legally bypasses the PERM process entirely. The petition belongs entirely to the individual.
Okay, let's unpack this, because it sounds like an absolute superpower, but there obviously has to be a rigorous standard.
No, there is.
What does it actually take to qualify for this? How does a single engineer prove to the U.S. government that she's a national asset? What does that paperwork even look like?
It is entirely about framing her daily work. The baseline requirement is that the applicant must hold an advanced degree, like a master's or a PhD, or they must possess exceptional ability in their field, meaning expertise significantly higher than what is ordinarily found.
Okay, that's the baseline.
Right, but
Yeah.
meeting that educational baseline just gets you in the door. The core of winning a national interest waiver is satisfying what adjudicators call the Dhanasar test.
The Dhanasar test.
Yeah.
The research from our legal team lays this out as a highly specific three-pronged test. Let's walk through them, because this is where the strategy gets brilliant.
Sure.
Prong 1. The proposed endeavor has substantial merit and national importance.
And this is where the context of the GPS Act is so crucial. When you are dealing with USCIS adjudicators, you have to remember they are government bureaucrats, not quantum physicists.
Right. They don't know what heterogeneous integration is.
Exactly. You have to translate the importance of sub-3 nanometer chiplets into legal reality. For a semiconductor engineer working in advanced packaging at a facility funded by the GPS Act, establishing national importance has literally never been easier.
Here's where it gets really interesting. Our research highlights a brilliant strategic point from attorney Chris M. Ingram on this exact dynamic. Congress essentially pre-approved prong 1 of the Dhanasar test without even realizing it when they passed the GPS Act.
They did all the work for you.
The U.S. government has explicitly committed $52 billion because it already determined the domestic semiconductor capability is a matter of critical national importance. The adjudicator reading Elena's file doesn't have to guess if her work is important. Congress already passed a $52 billion law declaring that it is.
That is the exact aha moment our legal team relies on. The Chick-Tuck Act isn't just background noise. It is the legislative proof doing the heavy lifting for the petition.
It's brilliant.
Which brings us to prong 2 of the Dhanasar test.
I had an excellent experience working with my caseworker Laura on my immigration case. She was consistently clear, organized, and communicative throughout the entire process. Laura always explained exactly what she needed from me to complete her drafts, which made everything feel straightforward and manageable. I'm very grateful for her help and would highly recommend Laura and the law offices of Chris M. Ingram to anyone looking for a reliable and dedicated immigration services.
The applicant must be well positioned to advance the proposed endeavor.
Meaning, okay, the field is important, but why are you the person to do it?
Exactly. And this is where Elena's specific technical record comes into play. You don't prove this by just having your boss write a letter saying you're a hard worker.
That won't cut it.
Not at all. You prove it through a paper trail of technical publications, patents, documented process innovations, and very specific expert letters.
Like actual evidence.
Yes. You don't need to have won a Nobel Prize. You don't need to be extraordinary in the absolute top 1% sense, but your work must be substantive, highly specific, and actively recognized by your peers in the industry.
And then we hit prong 3. On balance, it would be beneficial to the United States to waive the job offer and labor certification requirements, essentially proving why we should skip the PERM newspaper ads.
And again, the macro industry data argues this point perfectly for the applicant. When the Semiconductor Industry Association is officially projecting a shortfall of 67,000 workers, it definitively proves that the domestic pipeline is dry.
The workers just aren't there.
forcing a highly specialized advanced packaging engineer through a standard PERM labor certification, which exists to test the domestic labor market to protect U.S. workers, is completely illogical when the government and the industry have already concluded the domestic labor market is tens of thousands of workers short.
Right. Who exactly are you protecting? There's no one to protect.
Exactly.
I just love how elegant this legal strategy is. On one hand, the government created a massive $52 billion logistical problem by demanding these factories be built without enough domestic talent to run them.
Yep.
But on the other hand, the EB-2 NIW is the exact pre-existing legal key designed to unlock the human capital needed to solve that very problem. It's a perfect match.
It is a direct, flawless alignment of national policy goals and existing immigration law. As attorney Chris M. Ingram notes in the case files, the NIW was designed for exactly this kind of profile. The connection between the engineer's highly technical daily work and the broader national interest is direct, documentable, and undeniable.
So how did this actually play out in the real world for Elena? We know she needs the Dhanasar test. How did our legal team take this theory and construct the narrative to win the case?
Elena's petition was meticulously assembled by our researchers around 3 distinct pillars of evidence. We couldn't just say she was a good employee. We had to show the paper trail.
Right, the receipts.
The first pillar was her technical publications. She provided 2 peer-reviewed papers she had written on heterogeneous integration protocols, plus documentation of a major conference presentation she gave at the semi-annual Advanced Packaging Forum.
Nice.
This established her not just as a worker, but as an active knowledge creator pushing the boundaries of her field.
Okay, that covers the documentation, was the second pillar. Expert network, right.
Yes, the letters of recommendation. And again, these must be independent, distinguished researchers.
Not just her direct manager.
No. In her case, our team helped secure a letter from a prominent professor at Arizona State University's Semiconductor research program, and another from a senior engineer at a national laboratory who had actually independently cited Elena's published protocols in their own research.
That's the golden ticket, isn't it?
It absolutely is. It proves her work isn't just internal to her company, but is being utilized by the broader U.S. scientific community to advance the field.
And the third pillar is the framing. The briefing documents note a highly customized policy framing document prepared by the law offices of Chris M. Ingram.
This is crucial.
This wasn't just some generic template. This document explicitly connected her specific, highly technical daily contributions in thermal dynamics and chiplet assembly directly to the stated legislative goals of the CHIPS Act regarding domestic advanced packaging capability.
You tie the individual directly to the $52 billion national priority.
Brilliant.
And the result of this meticulously constructed strategy, a completely clean approval from USCIS. No request for evidence, no lengthy RFE delays. Because her priority date was current for Germany, her green card followed within just a few short months.
And the ripple effect of that approval is huge for her family. Her husband, who was sitting there in Arizona on a dependent H-4 visa and legally not allowed to work, was suddenly able to apply for his own work authorization.
That changes everything.
He got his employment authorization document, and now he works in Arizona's booming supply chain logistics sector, which is also experiencing massive growth because of the CHIPS Act. It completely stabilized their entire family's existence.
It is life-changing. It is so easy to get lost in the macroeconomics, the $52 billion, the global supply chains, the reticle limits of Moore's Law.
Yeah, the big numbers.
But looking at the actual client notes our legal team shared with us, you realize this is fundamentally about human relief. For instance, the research includes a message from an engineer named Neha, who wrote to express her heartfelt gratitude to the Chris M. Ingram Law Group. She called the approval of her case the most wonderful holiday gift.
Oh, that's amazing.
She specifically thanked her caseworkers Lazaro, Judith, and Jacqueline for their expertise, patience, and unwavering commitment. That is the emotional reality of a green card. It is the lifting of a massive psychological burden.
It really grounds the whole discussion. Behind all these astronomical numbers and geopolitical strategies, there are human beings who are just trying to build their lives, protect their families, and do important work.
Exactly.
And based on all of this, attorney Chris Ingram has outlined a very clear, highly actionable 4-step action plan for any semiconductor engineer currently working in the United States. Let's walk through it.
Step 1. Understand your leverage. You must realize that your specific field is explicitly on the national interest map.
The CHPS Act is basically your shield.
The CHIPS Act is your legal and policy infrastructure. If you work in advanced packaging, process development, yield improvement, or supply chain integration at a GPS-funded facility, you are already operating in a designated national priority area. The government has already validated your industry.
Step 2. Build your record deliberately. Don't just go to the clean room and do your job quietly.
Speak up.
You need to actively publish in peer-reviewed journals, present at recognized industry conferences like SEMI or IE, file patent applications, document your process innovations meticulously, track exactly who is citing your work. You are building a tangible paper trail of your expertise that an adjudicator can physically see.
Step 3. Identify your expert network. When it comes time to file the petition, you will need letters from researchers and practitioners who can speak to your specific technical contributions with deep, granular specificity.
Start thinking ahead.
Start thinking right now about who in your wider field outside of your direct managers truly understands the impact of your work on the broader scientific community.
And step 4, which might be the most crucial takeaway this entire deep dive, do not wait for your employer.
Do not wait.
The National Interest Waiver belongs entirely to you. It doesn't belong to your HR department. It doesn't depend on their quarterly budget priorities or their internal bureaucracy. Your contribution to American tech sovereignty is yours, and your immigration petition can be yours too.
This raises an incredibly important question, though. How many thousands of incredibly talented engineers are currently sitting in fabs right now, from Intel's massive Ohio complex to Samsung's Texas facility to all the cheap EPS-funded facilities springing up in New York and New Mexico, who simply do not know this self-petition pathway exists?
It's staggering to think about. They are just waiting anxiously on an H-1B lottery, entirely dependent on corporate whims, terrified of an arbitrary layoff when they hold the exact, precise skills the country is begging for to secure its future.
Think about the massive psychological shift for Alina. The case files note that when her final approval notification came through, she was literally in the middle of reviewing complex yield data from an overnight production run at the fab.
Wow, just in the middle of the work.
She read the email, forwarded it to her husband with a smiley face, and went right back to analyzing the data, but everything had fundamentally changed in that moment.
She was free.
She wasn't dependent on a lottery anymore. Today, she has her permanent green card. She has been promoted to lead a cross-functional packaging integration team. She is actively working on the advanced packaging protocols that will define how AI chips are assembled in the United States for years to come. She is permanent.
She is building the future.
Yeah.
And that brings us to a final thought I want you, the listener, to really mull over as we wrap up today.
Yeah.
We've spent all this time exploring how the United States is spending tens of billions of dollars trying to onshore its physical supply chains for national security. We're building massive concrete and steel factories in the desert. We are moving Earth. But it makes you wonder, in the 21st century, is true tech sovereignty actually about hoarding the physical factories? Or is it fundamentally about becoming the world's most irresistible magnet for the human minds that invent what goes inside them? If we win the global talent war, do the factories just naturally follow?
That is the critical question for the future of American innovation.
Thank you so much for being with us today. We hope you gained a lot from this discussion. Please leave us a comment if you can. Additionally, you can support our channel by sharing it with your friends and family, helping us build this community together. Also, follow us on Spotify, YouTube, LinkedIn, Facebook, X, and Instagram, where we're growing rapidly thanks to our social media team. We would also like to thank attorney Chris Ingram and his dedicated team once again for researching and preparing this material for our presentation. See you next time on Let's Talk U.S. Immigration.